Bedtime!
Hello, this is a famous problem that they say Google used to use in their interviews. It's called 2 eggs, 100 floors. So imagine there's a very tall building and it has 100 floors, okay? And there's 100 windows. And if an egg drops from the nth floor, it breaks. So from some floor, it's going to break. And if it dropped from any floor below, it will not break. And the assumption here is that if you drop it from a floor that it won't break, like say it doesn't break on floor 1, you can repeatedly drop it on floor 1 and it's not going to like damage the egg. That's one of the assumptions you're making. So Google here, they give you 2 eggs and they want you to find what floor will these eggs break using the least number of drops possible. Okay, and this is not such an easy problem. So first, the worst thing you could do is you could start at floor 1, drop the egg. If it doesn't break, you go to floor 2. If it doesn't break, you go to floor 3, then 4, then 5, and you keep going up until you find the floor that it breaks. Maybe it breaks at floor 62. But that took you 62 drops to get there. So that is not the very clever way of solving this problem. Let's say instead you think, I'm going to maybe start at the 50th floor. Seems like a good place to start. And you drop it from here. Well, let's work that out. If you drop the egg from here and it breaks, then you only have 1 egg left. And so to be safe, if you want to find this nth floor before your second egg breaks, you have to go down to floor 1 and drop it from there, then floor 2, floor 3, floor 4, and work your way up until you find that nth floor. And that could take you as many as 50 drops, because maybe you drop it at floor 50, it splats, but the nth floor could be at 49. So this is not a very efficient way. Let's say it doesn't splat when you drop it from floor 50, and you still have your 2 eggs. Well, that's great. So you know it's above floor 50, but you're going to run into the same problem. Because say you drop it from floor 75, you cut it in half again. If you drop it from floor 75 and it's flat, you're going to have to go 1 above floor 50 and check all of these floors until you find the nth floor. So there's a lot of worst case scenarios that are going to take several drops before you find this nth floor. So let's think of a different strategy. Let's say you divide the building into increments of 10. And you decide you're going to first start at floor 10 and drop the egg. And if it doesn't break, you go to floor 20 and you drop the egg. If it doesn't break, you keep going up at intervals of 10 until it breaks. So say it breaks here at floor 40. Since you've tried floor 30, you know the nth floor where it's not going to break. It's got it when it first breaks. It's got to be in between 30 and 40. So then with your second egg, you start doing the process of going 31, 32, 33, 34, 35 until you find that nth floor, the first floor that it breaks. Now the best case scenario for this method is it breaks at floor 10. If it breaks at floor 10, then the worst case scenario is that it's at floor 9 is the nth floor. And you had to check floor 1, 2, 3, 4, 5, 6, 7, 8, 9. That means a total of 10 drops. Let's say it breaks at floor 50. Well, it took you 5 drops to get there at the first egg. 1, 2, 3, 4, 5. So that's 5 drops. Then with the second egg, you got to try all the floors starting at 41, 42, 43, 44, 45, all the way to 59. And the worst case scenario is that, 49, that the egg breaks at floor 49. So that's an additional 9 drops, which is a total of 14 drops. And you can tell that the higher the floor that the first egg breaks, the more drops you're likely going to have. And again, I'm doing worst case scenarios here. So this method's pretty good, but say it was at floor 89. Say this magical nth floor was floor 89. It would take you 8 drops on the first egg. Sorry, 9 drops on the first egg before it broke. Because it'd break on floor 90, so it would take 9 drops. And then it would take 9 drops to get to 89, because you have to start at 81, 82, 83, all the way to 89. So it's another 9 drops, so it's a total of 18 drops. So now this method maybe doesn't seem like it's the best. It's still not bad, but it's definitely not the best. At this point, you may be thinking, it'd be good to have a method where the amount of drops for the worst case scenario is uniform. It doesn't change depending if the nth floor is very high or very low. So let's pretend that you drop the egg, your first drop is at some floor. We'll call it n. Okay, actually let's call it x because we are looking for the nth floor. So it's called x. So you drop it an egg at floor x. Now if it breaks, then the second egg, you kind of do the same thing you did when you did the increments of 10. You start at floor 1 here and you keep going up until you find this magical nth floor. So the most drops it would take if your first egg broke would be X drops, because your first drop it broke, and then the worst case scenario is it's the nth floor is the floor right below where your first drop was. So it's 1, and then you have to drop it all the way till you get right before that floor you started at. So that's going to be a total of X, whatever your X was. So let's say the other thing happens when you drop it from floor X, some random floor, that it doesn't break. Well, if it doesn't break, you still have 2 eggs. And since you're trying to make the worst case scenario always the same after each drop, your second drop here, this is the part you really have to understand, should be X minus 1 higher. So you go up X minus 1. So if X was, say, 10, you would go up 9 to the 19th floor. So the floor you go up to here is X plus 1, or X minus 1. Now, the reason that is because, say it breaks on this second drop here. If you want to have the same number of worst case scenario drops, then there has to be 1 less drop for the second egg. When you start going like this, and you check all the numbers before, it has to be 1 less floor in between there if you're going to end up with the same number of drops. And for the same reasoning, if you dropped it on your second drop here and it didn't break, again, you would have to go up by X minus 2. This distance here has to have 2 less floors in it, because when you want to always have the same number of worst case scenario drops. So this is X plus X minus 1 plus X minus 2. And again, if it dropped on this floor, you would check all these floors, and it would have the same worst case scenario amount of drops than if the first egg broke on floor X when you first started. Now, if that first egg continues not to break, say it doesn't break again, you're going to continue this pattern of adding 1 fewer floor when you go up to your next drop. The interval is going to be 1 shorter, till eventually the interval that you go up is just going to be 1. So this is the series of numbers that you are actually adding together. And again, X is this floor you're beginning with, the first drop of the egg. Now this right here is a series that is decreasing by 1 until it gets down to 1. And these are the triangular numbers, and this reduces down to, this right here equals, this is well known in math circles here, this equals x plus 1 divided by 2. And since the top of the building is 100th floor, you don't want to go past floor 100, right? You want this to end before you get to the top of the building. So what you do is, you set that equal to 100, and you solve. This is just a quadratic here, and you can solve for x, and you get a number 13.6 something, and if you want to round it to the nearest floor, which is 14. So this tells you that you should start on floor 14. And let me show you what you should do for each move after that. So on drop 1, you should be on floor 14. And if your egg does not drop, you go up 14 minus 1, which is 13 floors. So on drop 2, you're at floor 27. If your egg doesn't break again, you go up 13 minus 1, or 14 minus 2, they're both the same, which is to floor 39. So this is like the equation we wrote, and you keep going until your egg does break. Say on floor 4, on your 4th drop, it breaks. So on the 50th floor. Now you have to check now, the floors 40 to 49. You know one of those is going to be this nth floor you're looking for. So if it breaks on the 4th drop, you dropped it 4 times, and worst case scenario, the nth floor is 49. So you have to check 40, 41, 42, all the way to 49. So that is 10 extra drops. So 4 plus 10 would be 14 drops. That's worst case scenario if your first egg drops on the 4th drop. Now let's find the worst case scenario if it first egg breaks on, let's say, the 6th drop. If it breaks on the 6th drop, it is at floor 69, so you've done 6 drops. You're at 6 drops. And now you have to check all the floors from 61 to 68. And worst case scenario, it is on floor 68. So that's a total of 8 more floors you have to check. So 6 drops plus 8 drops is 14 drops again. So it's no surprise here. This is how we calculate it. Let's say the first egg dropped on the 1st floor. So that's 1 drop. And worst case scenario, now you have to check floors 1 to 13. Worst case scenario is that it's floor 13 is the nth floor. So you have to do 13 drops at the second egg, 1 drop at the first egg. That's again 14 drops. It's always going to be 14 drops as a worst case scenario unless the 100th floor is the nth floor. So there you have it. I know it's a bit of a confusing one there, This was given to people without any notice at Google during interviews. That goes to show just how kind of brilliant someone needs to be to work for that company. Okay, that's it.